Okay, and here we go, last two. So again, slightly trickier questions from factorizing, and this is, ooh, what do you think it is? So we've got a little memory stick here. Now let's first of all label up what we've got. Okay, so I don't need this, that's already on the sketch. RS and UT, yeah, so they're both the same, that's fine. RU and ST is 30, that's also on there, that's fine. And the diameter of the circle is 20, that's on. I've got a chord, which means it just cuts the circle, but not through the middle. That's fine. Calculate the length of the memory stick. Okay. So there's a circle with a bit missing. You should be thinking to yourself, Pythagoras in a circle. So up to here, that's 30, isn't it? So I now need to work out this distance and this distance. And actually, I already know this bit. That is simply the radius. That's 10. It goes from the centre to the edge, that's 10. So I just need to work out this little bit here. So that is going to be your classic. Now, right, I'll just draw it upside down because we're more used to that, I think. That's that upside down. So you draw in your little triangle. So the radius is 10. I'm trying to find that height. And this width here is 12. So that means the half of the width is 6. Okay, so I'll draw it on here as well just so you can see. But it's like doing this is 10. That's 6, and I'm trying to find x. Okay, and we'll add that to that. So it looks like a complicated question. It's not really. Pythagoras takeaway because I know the longest side's opposite the right angle. So x squared is 100, take away 36. So x squared is equal to 64. And you should have nice numbers here. So x is going to be 8. So that bit in there, the bit of the kind of hard bit is 8. And your final answer will therefore be 48. So the height is 30. Plus 8 plus 10 for 48 millimeters. Hard question in the sense of figuring out what's been asked, but in terms of the working, as you can see, not too bad. So you're getting a mark for drawing your triangle. I'll do it in blue. So right away, tick for doing that. Tick for your Pythagoras, for finishing your Pythagoras, and then for putting it all together. I'm not sure if you would get a mark for, stating 30 plus 10 plus x. I don't know if they would give you a mark for knowing that because you're not far off. I'm not sure, but look at that, 3 marks for doing Pythagoras. So you see a circle with a bit missing, you're thinking Pythagoras in a circle. And factorising. So usually, first of all, you always want to take a common factor. Right? Always take a common factor. Then from this, you will do something like either difference of two squares. So that would become x plus 3 and x take away 3. Or you do your trinomial. So maybe that's x squared, I'll say plus 20 plus 9x. So add to give you this, multiply to give you this. So it's going to be x plus 5 and x plus 4. Okay, fantastic. Or it's the harder trinomial when I've got a number in front of this, which is this one, and it's slightly different. You're still adding to give you this number, but you're multiplying to negative 30 this time. Not the last number, but this times this. So what adds to give you 13 and multiplies to give you negative 30? We'll just take your time. So 1 times 30 is a factor, 2 times 15, 3 times 10, 4 doesn't work, and 5 times 6. Okay, now that, one of these numbers could be negative, but it could also be the other number, couldn't it? It could be 1 times negative 30, it could be 2 times negative 15, 3 times negative 10, and 5 times negative 6. So which of these look like they're going to add to give me 13? There we go, that one in there, isn't it? Okay, so just take your time with your factors. Just take your time, write them out. If that was a positive number, I could have 2 positives and then 2 negatives. Okay? You don't have to write this out, you might be very good at it, but I'm just saying if you're struggling to spot it, just be systematic. So that's the same as plus 2x, take away 15x. Sorry, other way around, sorry. What am I saying? Come on. Not that one, no, this one, 15 take away 2. Uh-oh, rookie. So plus 15, so I'll write it with the 2 here. I'll say so take away 2x plus 15x take away 5 is equal to 0. So all I've done is rewrite the 13 like this. 13 is the same as 15 take away 2. Then you draw your little line down the middle and take a common factor out. In this case, I'll be taking out 2x. So that's 3x take away 1. Just check the time on the video. Yep. and you copy that bracket over, 3x take away 1, and you have to put a number in front of this bracket that would give you this. So if working back the way, how do I get from -1 to -5? Well, times it by 5 plus 5. Does that make sense? Yeah, it does. This would give you this, and that times that. And now you just put them together. You see you get 2x plus 5. I hate when my computer does this. It seems to then shift everything. And 3x take away 1. So I'm putting these two together, and I'm just bringing this bracket down. Absolutely. And solving means you need to take it to the next stage, which means, okay, this times this is 0. So either one of these brackets, either one, could be equal to 0. Yeah. So 2x plus 5 can also be equal to 0. And you just rearrange it to make x the subject. So add 1 to both sides, divide by 3. This one, take away 5, divide by 2. Usually, it's nice and easy like this, and all you're doing is changing the signs. You'd be saying that x is 3, and x is -3, x is -5, x is -4. And these are the actual roots where this equation crosses the x-axis. This one's slightly trickier, so you take away 5 and then divide by the 2. Okay. So, how did we get on then? What did you think? Let's just have a quick run through. So question number 1 that we could do was our fractions. Remember, do the whole number separate, unless it's a divide or a multiply, in which case you need to make your fractions top heavy. Multiplying the brackets out, you need to draw a little table for this or do your FOIL. And then you're grouping your like terms. Take your time to just highlight the sign in front of your number. Okay, but there's marks to be had for just breaking out both these brackets. Write down your rules for the angles. This is probably the most important one. This always comes up, the isosceles rule. Okay, that angle is the same as that because this length is a radius, this length is a radius, and it's like there's two little arrows kind of pointing at the two angles at the same. In this case, it's not quite as obvious. I've drawn it better here. But yeah, that's the big rule to remember. Your tangents at 90, angles in a semicircle 90. Half and half, and you've got a median, it's half the data, just chop it in half and then chop that top and bottom in half. Your interquartile range is Q3 take away Q1, and your semi of that is divided by 2. Don't forget for this, the K controls the steepness. All you have to do is substitute a point in. And if you're something similar to this number, we're moving to the right, and then we're moving up. So right 4, up 3. If that was a positive, we're moving to the left. Okay. Multiply your terms to get the same number in front of your letters, and then cancel them out. Okay, don't worry too much about the signs because you can add or subtract here. But you're multiplying both of them by something, so you've ratioed it so you're able to add and subtract. And don't forget to sub back in. Nature, you're doing your b squared minus 4ac. We talked about it. If b squared minus 4ac is less than 0, there's no roots. If it's equal to 0, there are two equal and real roots. If it's greater than 0, then you've got two real and distinct roots like that. Okay, so you're just doing that. You're given that whole formula at the beginning. This is where you'd be working out your roots with a calculator. This might come on the calculator paper. What are the roots of the function to 2 decimal places? You would use this whole function. But for nature, we just want the discriminant. For surds, we talked about our rules. Root 2 plus root 2 plus root 2. That's the same as 3 root 2. And you can rewrite your surds. You can go back the way, go forwards. But 4 times 5 is 20. 20 is 4 times 5. Root 4 is 2. Root 9 is 3. Root 16 is 4. Remember that. And this comes up for the statistics. Sometimes you get a statistics question on calculator. You might see that. Straight line, PGE. Remember that. You need to know your gradient formula, and you need to know your equation of a straight line formula. So get your points written out and label them, and just take your time. Okay, there was 2 marks to be had for the gradient and for the substitution. So don't worry if your algebra is a bit weak. But I would suggest when you do these, you're multiplying through by your fraction to get rid of it. But if you didn't like that, there are still 2 good marks to be had. Lots of words, but you're just picking out the numbers that you need, which are your coordinates, and then sum them back in. The 2 rules for equations: if you multiply or divide by negative, you need to flip the sign, and if you finish off like this, you need to put the x to the left, which again flips the sign. Reversing the change, start off with your line when you're trying to get back to 100. What you do to one side, you do to the other, and you can draw it out and look at it that way as well. This is the amplitude, that's how much you move it up and down. We didn't do that, I'm going to run out of time. But anyway, yeah, substituting in, yeah, change the sign, stays the same for your turning point, and Pythagoras in a circle. Hope that helps.